Hi everyone, in this video I'd like to talk about Jordan Canonical Form. So I won't talk about the theory so much as I will emphasize doing a few examples. So we want to find the Jordan Canonical Form. I'll abbreviate that as JCF for the following matrices. We've got matrix A, matrix B, and matrix C. The first step is to find the characteristic in the minimal polynomials and then deduce the invariant factors. Okay, so let's start off here. In a previous video, we determined that the characteristic polynomial for matrix A was x minus 1 times x minus 2 squared. We also figured out in a previous video that the minimal polynomial for A was x minus 1 times x minus 2 squared. And we went even further to figure out the invariant factors. And so the invariant factors for matrix A, well, we only had one, and it was x minus 1 times x minus 2 squared. It wasn't a very exciting example, but it was a good example nonetheless. Now, let's move on to step 2. For step 2, says find the elementary divisors, and here's how we do that. We write each invariant factor, and in our example here, we only have one invariant factor. We're going to write each invariant factor as a product of distinct linear factors to powers. So my elementary divisors, put this in a different color here, my elementary divisors in this example are x minus 1 to the first power and x minus 2 squared. Step 3 involves writing the Jordan blocks for each of the elementary divisors. I'll just say elementary divisor. I'll abbreviate that. So let's do that. So I'll write down here my Jordan canonical form for matrix A is going to be a 3x3 matrix. And the first little Jordan block that I'm going to work on here is the Jordan block for the elementary divisor x minus 1. And that's just going to be a 1 in the upper corner. And zeros everywhere else. The second Jordan block that I'm going to write down is the Jordan block for this elementary divisor, x minus 2 squared. So I have a little 2x2 matrix down here in this lower corner of my 3x3 matrix. And if I start writing the Jordan block there, I'm going to start with 2. And then in the last column, I'm going to have 1 and 2. So those eigenvalues are going right down the diagonal, and 1's in the diagonal just above that. So there's my Jordan canonical form. I'll write it without all the little dashed lines in it. It's just going to be 1, 0, 0, 0, 2, 1, and the bottom row 0, 0, 2. Now if we hop over to Maple, we can ask Maple to do that. I've typed in matrix A, and then the command is Jordan form. Make sure you have loaded your linear algebra package there. And here we see our Jordan form, and that's exactly what we had. Okay, let's go on and take a look at the Jordan canonical form for matrix B and C. So I'll make some space here on our board. So for matrix B, I'm going to start off with step 1. The characteristic polynomial for matrix B is x minus 1 times x minus 2 squared. We found that in a previous video. We also found the minimal polynomial in a previous video was x minus 1 times x minus 2. And even more information was previously obtained. We found the invariant factors were x minus 2 and x minus 1 times x minus 2. Now for step 2, we want to find the elementary divisors. So we're going to go through each invariant factor. The first invariant factor I'm going to look at here is the x minus 2. There is only one factor there, so the divisor I'm going to write down is x minus 2. I'm going to move on to my next invariant factor, which is x minus 1 times x minus 2. That's going to give me the elementary divisors, x minus 1 and an x minus 2. Step 3 is my Jordan canonical form. I'm going to write the blocks, the Jordan blocks corresponding to each of the elementary divisors. So the first elementary divisor there was x minus 2. That gives me a Jordan block, which is a 1 by 1 block, zeros everywhere else. Next, I'm looking at this entry in row 2, column 2, and that again is going to be a Jordan block of size 1 because my exponent on this factor, or this divisor, excuse me, is a 1. So I've got 1, zeros everywhere else, and the last elementary divisor in my list is x minus 2. That gives me a Jordan block of just 2. And so we see that the Jordan canonical form here is a diagonal matrix. What that implies is that B is similar to a diagonal matrix. And if we go through the steps for matrix C, recall that matrix C had the same minimal polynomial, so I'll just write that there. The minimal polynomial for C was the exact same thing. That means it's going to have the exact same invariant factors, elementary divisors, and so that the Jordan canonical form for matrix B and matrix C will be the same.